everyone. Prove that the inverse of A star B inverse equals B star A inverse. So we're going to let H be a subgroup of G and let R be the relation defined on G by A is related to B if and only if A star B inverse belongs to our subgroup H. So we're going to prove that our R, the relation, is an equivalence relation. So the first thing we're going to do is prove this part. All right, so basically we're going to consider A star B inverse star B star A inverse. All right, now this is going to equal A, by associativity, A star B inverse star B star A inverse. So this equals E A star E star A inverse. And that's definition of inverse. Okay, and this was a associative property here. All right, and then A star A inverse, and that's definition of identity. And then this equals E, which is definition of inverse. So therefore, because of this, A star B inverse equals B star A inverse. All right. So now we have to prove it's an equivalence relation, and we're going to let H be the subgroup of G. So basically what we're going to do is say that A, for reflexive, remember we have to do before we get started, recall through an equivalence relation, we need that R is reflexive, symmetric, and transitive. Okay, so let's start here. So to prove this, it's given, this is what's the subgroup here. So what we want to write is A is related to A if and only if A star A inverse belongs to our subgroup H. So that means E belongs to our subgroup H, which is true because H must contain the identity. Okay, so it is reflexive. Now for symmetric, we want A related to B if and only if, and we're looking at this, A star B inverse belongs to our subgroup. So what we're going to do is do the inverse of this. And we know this is already equal from here. This equals B star A inverse. So since every inverse of element in H must also be in H, so every element in H must have an inverse. Therefore, R is symmetric. All right, here R is reflexive. Okay, and then for the last one, we want to prove transitivity. So we have A, R, B, if and only if A, we're looking at this, star B inverse belongs to H, and then we have to add B, R, C, if and only if B star C inverse belongs to our subgroup H. So then we have A star B inverse star B star C inverse. This inverse should go on the inside. Belongs to H, since H is closed. This is because H is closed. All right. So by associativity, we have A star B inverse star B star C inverse belongs to H. And so that's A star E star C inverse, which belongs to H. And therefore, A star C inverse by identity belongs to H. All right, or by inverse. So basically, R is transitive. Okay, so we have proved that R is symmetric, reflexive, symmetric, transitive. Therefore, R is an equivalence relation. And that's it. Thank you. Have a nice day. Bye-bye.